Alright, so this is the first page of your review packet. Let's just go ahead and go through some of these together. I'm going to start with number 1. Because this is x minus 5, that means I can put a 5 here, and then I have the 4x to the third, negative 22x squared, positive 12x, and minus 10. So I'm going to bring down the 4, multiply it times 5 is 20, negative 22 plus 20 is negative 2, times 5 is negative 10, 12 plus negative 10 is 2, and 5 times 2 is 10. Negative 10 plus 10 is 0. So my answer then would be 4x squared minus 2x plus 2, remainder 0. Let's go on to number 2. Find a quadratic regression line for this data. So I'm going to use my calculator for this, and you should too. I'm going to go ahead and start by pressing the Stat button and Edit. And I'm just going to remove the stuff that I currently have in here, so I'm clearing the first list. And then list 1 are going to be my x values, which is 1, 2, 3, 4, 5, and 6. And I'm going to move over to list 2, which is 50, and 65, 70, 64, 48, and 20. Oops, 20. And then I'm going to go back to Stat. Calculate. It says to calculate a quadratic regression line, so I'm going to go down to quad reg. My x values are in list 1, my y values are in list 2. I don't really need to store this, I think, but I'm going to store it in variables, y variables, function y1, and I'm going to go down and calculate that. So you can see that my equation is y equals negative 5.339 x squared plus 31.46x, and then plus 23.7. Then it says for number 3, what is the value of y when x is 9? So you can go ahead and press the graph features, and it looks like there's already something on here. So I'm gonna clear my graph, get rid of my plot 1. But then what I can do is, if I go to the graph, there's my equation. I'm not sure what my window is, but if I go to second trace, and I go to a value, now I can just type in x equals 9, press enter, and it'll tell me that the y value is negative 125, negative 125.6357. The other thing that I could have done here is I could have actually plugged 9 into this equation and got something really close to that, depending on how I rounded. But that was number 3. Number 4, I'm going to solve for x, state the restrictions on the variables. So I'm going to start by adding 3. I'll have ax plus bx equals negative 11 plus 3, which is negative 8. Then I'm going to factor out the x. So it's going to be x times a plus b equals negative 8. If I divide both sides by a plus b, then I'll have negative 8 divided by a plus b. This is really important because there is a restriction here. A plus b cannot be 0. That's the restriction. Because if it is, then I'm dividing by a 0, and I can't do that. That's undefined. Take a look at number 5. Mark has 70 nickels, dimes, and quarters. So the number of nickels plus the number of dimes plus the number of quarters is equal to 70. They're worth $7.75. So what I'm going to do is say 5 cents for each nickel plus 10 cents for each dime plus 25 cents for each quarter equals 775 cents. Then it says the number of nickels is 10 less than the sum of the dimes and quarters. So the number of nickels does not equal the dimes and the quarters. This is 10 less. So what I'm going to do is add 10 to the number of nickels so that now it's equal to the dimes and the quarters. And I'm going to solve this equation. I would probably do it like this. I would get the bottom equation and solve that for n, and it would look something like this. I would have n equals d plus q minus 10. So if I were to stick that into the top equation here, stick this in for n, I would have d plus q minus 10 plus d plus q equals 70. So I'm going to do a lot of this in my head here. That means I'm going to have 2 d's plus 2 q's, and if I add 10 to the other side, that's going to equal 80. If I do the same kind of thing with the next equation, it's going to be 5 times this whole thing, because that's n, plus 10d plus 25q equals 775. Well, if I plug d plus q minus 10 in for this n, I'm going to have 5d plus this 10d, that's 15d. I'm also going to have 5 times q plus this 25q is 30q. Then I'm also going to have 5 times negative 10, which is negative 50. But if I add that to the other side, add 50, that's going to be 825. So this would be my two equations with two variables. And what I'd want to do then is maybe multiply the top equation here by negative 15, so that I would have a negative 30q and a positive 30q, and then those could be eliminated. If I do that, this is going to be negative 30d minus 30q equals 8 times 15, and here I'm going to have to cheat a little bit. I'm going to go to 15 times 80, which is 1,200. And then when I add these together, of course my q's are going to be eliminated, but I'm going to have negative, let me put it over here, negative 15d is going to equal 1,200 plus 825, which is 2,025. So if I take, and let's see, one of those should be negative. No, that's not right then. So this is going to be not negative 2,000. It's going to be 1,200 minus 825. But that's going to be negative, which I think is negative 375. Because I forgot to make that negative. So then, if I take 375 and I divide that by 15, I get 25. So the number of dimes is 25. Then I'm just going to work backwards to figure out the number of nickels and the number of quarters. And so, for example, if I wanted to, let's say I want to use one of these equations, let's say this top equation here, the number of dimes is 25, that's 2 times 25, which is 50. If I subtract 50 from 80, that's 30. Then divide by 2, the number of quarters is going to be 15. And if I add the dimes and the quarters from this equation, that's 25 plus 15, which is 40, minus 10, that means the number of nickels is going to be 30. So, kind of run out of room there, but hopefully you got the idea there. Take a look at number 6. So here's number 6. We're going to solve this system of inequalities by graphing. The first thing I'm going to do is graph x is greater than or equal to negative 1. Well, here are the x values that are equal to negative 1, but I want the x values that are greater than or equal to that, which means I'm going to shade everything on the right-hand side. Here's the y values that are equal to negative 3. Now this is going to be a dotted line because I want the y values that are just greater than negative 3, which is just the ones up here. So the part that's shaded twice is this area in here. It does not include this line because it's a dotted line, but it does include the line that x is greater than or equal to negative 1. Let's move on. Take a look at number 7. We're going to write a quadratic equation in vertex form that has a vertex here at negative 540 and goes through this point. So here's what this is going to look like at the beginning. I'm going to take, I know vertex form is a times x minus h squared plus k. That's something you need to know. I know the vertex is the hk, so that means it's going to look something like this. I'll have y equals a times x minus a negative 5, which is plus 5 squared, and then plus 40. But I don't know the a value. But what I can do is I can plug this point in. Here's my x and my y. That means y is 8 equals a times x, which is negative 1 plus 5 squared plus 40. Well, that's 4 squared is 16. So 16a plus 40 equals 8. If I subtract 40 from both sides, that's going to be negative 32 equals 16a, and a is negative 2 if I divide by 16. So my final equation then is going to be y equals negative 2 times x plus 5 squared plus 40. Let's move on. Take a look at number 8. Now, number 8 in class we changed. The first equation is y is less than or equal to negative x plus 200. So maybe your eyes are better than mine and you guys can read these things here. Looks like this is 20, 40, 60, 80, 100, 120, 140, 160, 180. Here's 200. And here's 20, 40, 60, 80, 100, 120, 140, 160, 180. That's 100, 120, 140, 160, 180. Here's 200. So this is going to start at 200, and it's going to have a slope of -1, which means I go down 1 over 1, or I can go down 200 and over 200. So it's going to be this entire line that connects those 2 points. Well, that's the first equation. Then I want to graph the second equation. Now I want the x values that are greater than or equal to 0 and less than or equal to 150. So here's my x values. Here's where it's 100, here's 120, 140. 150 is going to be about right here. So I want it to be less than that, but greater than 0. So far it's underneath this line, it's to the right of this line, and I guess it's above 0 also, so it's in the first quadrant. Then if I look at the y value, it's less than or equal to 120. Well, here's where y is 120 and 0, so it's going to be somewhere in there. Where is it shaded twice or all 3 times? Well, that's going to be this little area here. If I move on to number 9 then, it says find the maximum value for the objective function. Well, that means I'm going to have to plug in this point, and this point, and this point, and this point. And actually, I probably don't need to plug in those, because if I have, looks like this is where x is 0 and y is 120. Well, that's going to give me a certain profit, but this point right here, it looks like that is where x is 100 and y is, no, maybe that's 80. That's 80 and y is 120. And that would make sense because these have to add up to 200. If I took, if x is negative, if x is 80, then this is negative 80 plus 200, which is 120. So this is one point. That looks really sloppy, but that's the point 80 and 120. This point here is 150, 0. That's going to give me a certain profit, but if that gives me a certain profit, this is going to give me something more, 150 and 50. And that's because if x is 150, negative 150 plus 200 is 50. That's where these 2 lines intersect. And so I'm going to test, this is 150 and 50. I'm going to test these 2 points and see which one gives me the most profit. If I were to do the first point, I would have 8 times 120 plus 8 times 80 plus 9 times 120. That gives me a value of a profit of $1,720. It's pretty good. Let's see if this one gives me something bigger. If I let x be 150, that's going to be 8 times 150 plus 9 times 50. That gives me a profit of $1,650. If I maximize the profit, I'm going to use this point, and my maximum value, my maximum profit, if this is profit, is going to be $1,720. Let's move on and take a look at number 9. We're going to solve this system. It's just a 2 by 2, so what I'm going to do is take this top equation and multiply it times 3. That'll give me a negative 3x, a negative 6y, and a negative 3. And I'm going to add these 2 equations together. The x's will be eliminated. Negative y and a negative 6y is negative 7y. 17 and a negative 3 is positive 14. And if I divide by negative 7, y is negative 2. So I'm going to use this equation here. This is 3x minus negative 2. That's plus 2 equals 17. Well, if I subtract 2 from both sides, I'll get that 3x equals 15. Divide by 3, and x is 5. So my answer would be the point 5, negative 2. Number 10, we want to describe the transformation that would map the parent function, which is this, onto this function here. Well, this x minus 5 here is going to move it 5 to the right. That's one transformation. This negative 2 here is going to move it 2 down. Then this negative 3 is going to do 2 things. One thing that it's going to do is it's going to stretch it by a factor of 3. The other thing that it's going to do is it's going to flip it over the x-axis because it's negative. And so those are the 4 transformations that's going to happen in number 10. Number 11, we want to graph this equation. So that's the same kind of concept here. I'm going to move 3 units to the left, my vertex, which is normally at the origin. Also 3 units up. So it's going to start here. So 3 units to the left is this one. 3 units up is this one. But then it's going to open down. And so my V, which normally goes over 1 and up 1, now is going to go down, and it's going to look something like this. And then the last one, number 12 on this page, says write a polynomial function with the following zeros. Well, here's what this means. One factor is going to be x minus 4. Another factor is going to be x minus 3 minus 2i. And another factor is going to be x minus the conjugate of that, which is 3 plus 2i. I want to multiply these together first. This is where it gets ugly, and then a lot of the stuff cancels out. I would start by doing this. I would distribute this negative sign. This is going to be x minus 3 plus 2i times this one, which is x minus 3 minus 2i. So I'm going to start by multiplying this x out. I'm going to have x times x, which is x squared. X times negative 3 is negative 3x. X times negative 2i is negative 2xi. Then if I multiply the negative 3 out, this is going to be negative 3x. Negative 3 times negative 3 is positive 9. Negative 3 times negative 2i is positive 6i. Then I'm going to multiply the 2i out. 2i times x is 2xi. 2i times negative 3 is negative 6i. 2i times negative 2i is negative 4i squared. Well, that's negative 4 times negative 1, which is really positive 4. So if I simplify all of this, I'm going to have x squared. The negative 3x and negative 3x is going to be negative 6x, but negative 2xi and positive 2xi will cancel out. 6i and negative 6i will cancel each other out. And 9 plus 4 is 13. Then I'm going to take that whole thing and multiply it times x minus 4. I'm going to move this up a little bit so you guys can see that. I'm going to start by taking the x and multiplying it out. X times x squared is x to the third. X times negative 6x is negative 6x squared. X times 13 is 13x. Then if I multiply the negative 4 out, this is going to be negative 4x squared. Negative 4 times negative 6 is positive 24x. And then negative 4 times 13 is negative 52. Combining like terms then, I will have y equals x to the third. A negative 6x squared and a negative 4x squared is a negative 10x squared. A 13x plus a 24x is a 37x. And then minus 52. And that is my equation in standard form. Guys, that's page 1. And we will, if you want to go over questions on page 2, go to the next video.